I guess I should talk. Okay, finding sines and cosines of angles on an axis. So when you're on an axis, let me change to blue. Okay, when you're on an axis, so you're either going to be at 90 degrees, 180 degrees, 270 degrees. This is 0 and 360 degrees. So for a quadrantial angle, that's a different word, the corresponding point of the unit circle falls on the x or y axis. In that case, we can easily calculate the sine and cosine from the values of x and y. So if you think about, you're on a unit circle, so here your x is going to be 1, but your y is 0. Up here, your x is 0, your y is 1. Over here, your x is negative 1, because x is negative over there, y is 0. And down here, your x is 0, and your y is negative 1. And just think about that. On the x-axis, y is 0, so that's why it's 0 here. On the y-axis, x is 0, so that's why those are 0 here. Y is 0 on the x-axis. So, find cosine of 90 degrees and sine of 90 degrees. So cosine of 90 degrees, we're going to go to this top one here. Well, it's going to be the x value, so that's 0. Sine of 90 degrees is also up there. That's the y value, that's 1. See how fun that was? Okay. Now, we're going to talk about the Pythagorean identity. So you've heard about the Pythagorean theorem. We know that in a right triangle, the sum of the squares of the sides, so a squared plus b squared equals c squared, equals the square of the hypotenuse. Come on, erase. There we go. So we can translate that into this unit circle. X squared plus y squared is 1 squared, or x squared plus y squared is 1. But x is cosine t, and y equals sine t. So it's going to be cosine squared plus sine squared is 1. So the Pythagorean identity states that for any real number t, cosine squared plus sine squared, sorry, cosine squared t plus sine squared t is 1. And I want to be really clear about the notation here. This is saying cosine of t quantity squared plus sine of t quantity squared equals 1. But we write it with that squared after the cosine. If we wrote it after the t, it looked like it was the cosine of t squared. And so not meaning this. So how to find cosine of t given the sine t and its quadrant location? Substitute the known value of sine t into the Pythagorean identity. Solve for cosine t. So choose the solution with the appropriate sign. It should be positive or negative. Think about where it's located. So if sine t is 3/7 and t is in second quadrant, find cosine t. Okay, so we know that cosine squared t plus sine squared t equals 1. So cosine squared t plus 3/7 squared equals 1. So cosine squared t plus 9/49 is 1. Cosine squared t equals 1 minus 9 over 49, which is 49 over 49 minus 9 over 49, which is 40 over 49. So cosine of t would be plus or minus the square root of 40 over 49. We could simplify that a little bit. 40, there's a 4 and a 10. There's 8 and 5, but that's not going to do anything. So we'll go with 4 and 10. So do 2 root 10. And the square root of 49 is 7. Now it says it's in the second quadrant. So second quadrant means it's over here. So it's over in this area. So notice that x is negative over there. So our cosine of t would be negative 2 root 10 over 7. And that's it for that.